Hello and welcome to AP Calculus Lecture 3.6, Summary of Curve Sketching. Go ahead and get out your note sheet and we'll go through this. I'll highlight a few items on it, then we'll work some example problems and I'll sign the homework. Everything on here is a review, so really no new material today. Everything is going to coalesce together, 3.3, 3.4, 3.5 all together, and then where we also learned critical points. So a summary of curve sketching. The first thing you're going to do is find critical points. So you set f prime of x equal to 0 and solve. Then we're going to do the first derivative test, and we're going to use a sine line to determine where the function is increasing or decreasing. So here's an example of a sine line of the first derivative, and then you're going to determine the increasing and decreasing intervals based on whether the derivative is positive or negative. And then we're going to determine the maximum and minimums if there are any. And we're going to get the point xy where there's a maximum or minimum. All right, and then we get the y values by plugging back into the original equation. So don't accidentally plug it back into the derivative. Then to determine concavity, we're going to take the second derivative test. All right, and we're going to use a sine line. We're going to set the second derivative, f double prime of x, equal to 0 and solve for the inflection points. We determine the y value of the inflection point by plugging into the original equation f of x. We determine concavity utilizing the intervals, utilizing the sign chart. Positive intervals are concave up. Negative intervals are concave down. All right. So then we're going to determine any vertical asymptotes. We just did that in the last section. Factor and cancel if necessary. The vertical asymptote exists where the denominator is equal to 0 unless it cancels. If it cancels, then it's a whole when factors cancel. Then we're going to determine the horizontal asymptotes. All right, we take the limit as x approaches infinity. All right, and if the limit exists, the horizontal asymptote exists. If it doesn't exist, no ha. And you know, we can use that test of where the top wins, the bottom wins, or it's a tie in terms of the highest power. And then the last thing we do is sketch the graph based on the above information. And you do not get a graphing calculator on the test. So you want to do this without using a graphing calculator. You'll only get just a standard calculator. Okay, let's work a couple of examples from the book. All right, we're going to start with number 11. And we are on page 203 if you want to flip to that real quick. Okay, so we're going to do the whole thing. We're going to find everything that we've learned how to do and then sketch the graph. So let's say we have f of x is equal to 3x cubed minus 9x plus 1. Now, I like to do the easy things first. Let's find if there is a horizontal or a vertical asymptote. Well, this is not a fraction. There's no denominator. So there's going to be no vertical asymptote and no horizontal asymptote. And you want to write that down because you can get partial credit. You start to accumulate points like this. There's 2 of these problems on the test where you have to do every single thing, and they're both worth 16 points. So you want to accumulate all the points you can. Now we're going to take the first derivative All right, so that's going to be 9x squared minus 9. We're going to set that equal to 0. Okay, so our critical points, now I can, if you want, you can go ahead and factor out a 9, solve for x, but I can kind of eyeball this one and see that x is equal to plus or minus 1. Either of those will make this derivative equal to 0. So I like to draw my sign line right next to the derivative. And remember, go from left to right, negative, least to most. If you get that backwards, you will mess up the whole problem. Okay, let's take a look at a number that's less than negative 1. I'm going to try negative 10. That'd be 9 times 100 minus 9, so that would be positive. Let's pick 0 for this interval here. That's going to be negative 9, so that's negative. And then greater than 1, the derivative would be positive. All right, so I like to draw my arrows. It makes it so easy to see. So we would have a maximum right here and a minimum right here. Okay, let's go ahead and write that down. We have a maximum at the point negative 1, and then we want to plug back into the original. That's going to be 3 times negative 1, negative 3, plus 9. Negative 3 plus 9 would be 6 plus 1 is 7. We're going to have a minimum at the point 1. So I'd have 3 minus 9. That's negative 6 plus 1, negative 5. We are increasing from negative infinity to negative 1, and also from 1 to infinity. Then we are decreasing from negative 1 to 1. So we've already answered 1, 2, 3, 4, 5, 6, and I forgot to write down the critical points. Let's go ahead and write that in. You've gotten more than half. Critical points are at x equals plus or minus 1. You've gotten more than half of the problem already. Okay, let's do the second derivative test. So we have the second derivative, f double prime of x. We're going to take the derivative right here. That's going to be 18x. Set that equal to 0. And so we have an inflection point at x equals 0. So I'm going to go ahead, as I gather the information, I'm going to write it over to the side here. 0, plug 0 in, it'd be at 0, 1. Okay, let's do a sign line next to the second derivative. All right, to the left, put a negative 1 in there. It's negative. So that's concave down. To the right, it's going to be 18 times a positive number, so that would be concave up. So we have concave down from negative infinity to 0, and concave up from 0 to infinity. Okay, we have gathered all our information, so that's going to be 12 points on this problem on the test, 12 out of your 16. And then the last 4 points will be from the graph. Okay, so let's take a look here. I like to plot the max and the min. So the max over 1, up 7. You don't have to draw the tick marks. Just make a good estimate. So we'll say that's the max. The minimum over to the right 1 and down 5. So something like that. We have an inflection point at the point 0, 1, so I'm going to say that's about right there. We are concave down until we get to 0. Okay, and then we are decreasing till we get to 1. So we're still going down, but this time the bowl kind of changes there. And we are concave up then from this point 0 to infinity, and concave down there. So it switches there at the inflection point. We can say this is -5. This inflection point's at 0, 1. And that is enough for me. No asymptotes to draw, so no dashed lines. And there you go. You can guarantee that one of your test problems will be of about this difficulty. All right, let's do one that's got some asymptotes in it, okay? One that's a little bit different. Okay, our next example is not from the book, but we have f of x is equal to 3 plus 2 over x. So I'm going to rewrite that as f of x is equal to 3 plus 2x to the minus 1. So first of all, let's get the horizontal asymptote and the vertical asymptote if there is one. So where is at what x value is this function undefined? And it's at x equals 0. It doesn't really matter. There's a 3 over here. 3 plus 2 over 0 still is undefined. So we have a vertical asymptote at x equal 0. Now, do we have a horizontal asymptote? Well, to find that, I'm going to do that down here. We take the limit as x approaches infinity of 3 plus 2 over x. So that's going to be 3 plus, if you plug infinity in here for x, 2 over infinity is 0. So 3 plus 0, which is 3. So we have a horizontal asymptote at y equals 3. All right, that's a pretty good start. Now, I'm going to go ahead and erase this so I have room to do the rest, but feel free to leave it on there. So we did have a homework problem that kind of looked like that. Now let's take the first derivative, f prime of x would be minus 2x to the minus 2. That is negative 2 over x squared. Now that is never going to be 0, right? Because you have a negative 2 on top. 0 occurs when you have a 0 on top. Okay, however, you do have a critical point where the function is undefined, and that's going to be at x equals 0. So we know we had an asymptote at x equals 0, vertical asymptote. So I'm going to put our critical point here. I like to, when there's an asymptote there, just put VA right there. You don't have to, but that's good information. All right, to the left of 0, whatever you put in here is going to be positive. So it's negative over a positive because it's squared. Okay, so negative 2 over a positive, negative over a positive is always negative. So it's going to be that way on both sides. So this function is always decreasing. Okay, so I'm going to go ahead and write that down. We are increasing never. So I'm just going to put none. And we're decreasing from negative infinity to 0 and from 0 to infinity. Now you can't say in this case from negative infinity to infinity because there's an asymptote there at 0. So at 0 it's not decreasing. Okay, do we have a max or min? No, these arrows never come together up at the top or up at the bottom. It's always decreasing. So there's no max and no min. All right, we've gained a lot of points, right? We've gained a lot of points. At least half credit we've gotten so far. Okay, let's take the second derivative. That's going to be negative 2 times negative 2, 4x to the minus 3. Okay, so I'm going to rewrite that as 4 over x cubed. Now, can that be 0? You know, no, it can. It's never going to be 0, but we do have an inflection point where that second derivative is undefined. So just like the critical point at x equals 0. Okay, it's undefined there. Let's go ahead and do our sign line. Negative infinity, infinity. And put our inflection point there at 0. There's also an asymptote there, so it's going to change concavity potentially at the asymptote. Okay, so a number to the left of 0, let's say negative 1. We plug in negative 1. 4 over negative 1 cubed is negative 4, so it's negative. And we are concave down. To the right, 4 over a positive number, we are concave up. So let's go ahead and write that information. We have an inflection point. Now, I don't have a y value here because it's undefined. If you plug 0 back up here, it's undefined. So I can only give the x value. That's x equals 0. We are concave down from negative infinity to 0. And we're concave up from 0 to infinity. So we have, if you got them all right, you've gotten 12 out of your 16 points on the test. Okay, so that's awesome. Now let's sketch the graph. So we've got a vertical asymptote, and I'm going to put these in red, vertical asymptote right along the y-axis at x equals 0. So I just put it right next to it. We have a horizontal asymptote. Now let me use a different color. We'll do green at y equals 3. I hope that's coming through on the video. So that is y equals 3 and x equals 0. All right, so to the left, it's always decreasing. It's always going down, this function. But you can't pierce the asymptotes. We can't pierce the red dashed line. We can't pierce the green dashed line. So on the left side of the graph, it's concave down. So this is how it would have to be. And then it goes down forever. So that way it doesn't pierce either side, either asymptote. And here it's still decreasing on the right side, so I don't want to draw it up because that would be increasing. How can I draw decreasing without piercing the asymptotes? It would be like this, and it's concave up also. So that's a pretty cool looking graph. Always decreasing, concave down, concave up. All right, so sometimes you have to think that through. You might draw it wrong first, so draw it lightly and say, oh, wait a second. That's, if I drew it this way, then it would be increasing, not decreasing. So, and if I drew it down this way, then the tail of that would pierce the green dashed line, pierce the asymptote. All right, so that does it for our 2 examples. So this is a great homework exercise. It really is going to, it's a fairly long homework exercise, but it is super valuable. And if you do all of these, then you're super prepared for the test. So our homework starts on page 203. Right? You're going to do 7, 13, 18, 29, and 34. Okay, so on this, I want you to give everything. So your instructions are: find the critical point, the intervals where they're increasing, decreasing, max if there is one, a minimum if there is, could be more than one, but max, min. Find inflection points. Where is it concave up? Where is it concave down? And then vertical asymptotes, horizontal asymptotes, and a rough sketch of the graph. So this prepares you for the two largest point problems on the test. There's two 16-point problems on the test where you have to do all this. So give it a go. The back of the book has a graph, so you should be able to find, you should be able to read that graph and see if you got it right. If you have trouble with that, then you can just watch the solutions video. Show all your work. Do it just like I did in the examples. Take your time. This assignment will take you, it could take you longer than usual, but it is a great assignment. And I will talk to you on the solutions video.